Outstanding performance. At the track or on the road, it begins with an outstanding power plant. Building an outstanding power plant begins with an outstanding casting facility, such as Ford's Cleveland Casting Plant. Located south of Cleveland, Ohio, near the shore of Lake Erie, Cleveland Casting began operations in 1952. Since then, the plant has employed thousands of people and contributed to the development of the surrounding community. Today, the plant produces 300,000 tons of castings annually, with greater efficiency and at higher quality levels than ever before. It is one of the leading casting plants in the world. Blocks for the entire line of new generation engines found in today's best-selling Ford trucks are produced at Cleveland Casting, including the 4.6, 5.4, and 6.8 liter engines. Using a Ford patented process, a number of improvements have been incorporated into the casting of these blocks. For example, fixtures are now used to position the cores. With the modules in place, sand is blown in to lock the core package together. T-lock water jackets improve stability and dimensional control, and head slabs provide stability to the head deck openings. As part of the plant's ongoing commitment to a better work environment, the process has also been improved ergonomically, with assembly fixtures that tilt for side core and water jacket installation, and a side core slide mechanism that opens automatically. The automated process washes the core package and places it in the oven. Then it is unloaded, placed into a fixture, and transported to the molding area. Here, it is set into the drag, the lower half of the mold, which is mated to the cope, the upper half. Filling the pressure pour furnaces has been changed from a manual to an automatic operation for more accurate pouring. After it has cooled down, the casting is run through shakers to remove the sand. Later, it is sent to a finishing area where the metal flashing is removed. Products produced at Cleveland Casting include bearing caps, flywheels, camshafts, crankshafts, and cylinder heads, as well as inline cylinder blocks for the 1.9 liter and 4.9 liter engines, and V-blocks for the 4.6 liter and 3 liter engines. The block for Ford Ranger's new 2.3 liter overhead cam engine is also cast at Cleveland, using a flaskless molding process. Cleveland Casting is one of only a few operations in the world to use this advanced process to produce cylinder blocks. Core packages are either advanced directly to the molding line or sent to an auto-load storage system, which relieves employees from having to physically handle the 85-pound assemblies. Cores that advance directly to the line are placed into the mold by a core mask. A ram and swing form the mold. Cores are then positioned inside the mold to form the internal passages of the cylinder block. The metal is poured, the casting is made, and then removed and sent on for cleaning. The pattern shop at the Cleveland Casting Plant is a climate-controlled environment, one of the most advanced of its kind. The shop's new Picasso videophone system makes it possible to send a casting image by wire, so that the plant can provide customers or suppliers with the information they need to change or improve a design. And since all part designing is now done on computer instead of with blueprints, the information is downloaded directly to CNC machines, which automatically cut the actual part with a high degree of accuracy. The shop is also working with a rapid prototyping software program, which will shorten design time from months to hours. But perhaps the most impressive part of the Pattern Shop story is that these improvements were made directly by the Pattern Shop team, providing the plant with a customized process for maximum productivity and efficiency. The Prototype Development Center is another example of Cleveland Casting's advanced approach to R&D. A foundry within a foundry, the Prototype Development Center has its own melting ovens, furnace, and core machines for prototype testing. Here, employees can mix any metal, make any kind of core, and produce any kind of casting the plant might need so that it can be tested and proven before being put into production. Cleveland Casting's Quality Lab is also a state-of-the-art operation with a new $500,000 automated spectrometer system. After a sample has been ground, a computerized self-calibrating spectrometer with its own robotic arm picks the sample up and takes 2 readings. It then determines if the readings are within an acceptable range, averages them, and provides a report. This automated standardization and result verification process provides plant employees with more accurate information for better product quality. And at Cleveland Casting, quality is something that goes beyond the product. In recent years, the quality of the plant itself has improved considerably. For example, the Cleveland Casting plant serves as a huge recycling facility for the entire community, processing clean scrap metal that would otherwise end up in landfills. Foundry sand that was once disposed of is now being reused as part of a new recycling program that benefits everyone. Water used for cooling is treated, cycled into one of the plant's 8-million-gallon ponds, and then used again. Even the plant's air is filtered to protect the environment and make Cleveland Casting a healthier place to work. Today, more than ever before, the plant is working in harmony with employees and unions to provide a better and safer workplace. The Cleveland Casting plant is the Ford powertrain pilot site for the Sharp process in which area safety teams work together to improve the safety of the work environment. In addition to improved safety, ergonomics are also being improved throughout the plant, as well as in office and computer areas, making the entire facility more user-friendly. There are also 14 DCP, Dynamic Control Plan teams, working together throughout the plant to gain a better overall understanding of the casting process as part of a continuous effort to produce a better product. The effectiveness of the cross-functional team approach in preventing defects and delays and in ultimately improving product quality is also becoming increasingly evident. FTPM, Ford Total Productive Maintenance, is another way in which cross-functional teams are working together to continuously improve the reliability and output of the entire Cleveland Casting facility. And this is just a small example of the many teams working together within the plant to minimize downtime, improve reliability and efficiency, and ensure continuously high levels of product quality. As evidence of its commitment to employees, the plant opened its own fitness center, which currently has 800 members. Facilities include an impressive range of state-of-the-art exercise machines, group programs, and a full-time training staff. The Cleveland Casting plant is also one of 3 Ford facilities in the world that operates its own licensed rehabilitation center. And beyond its employees, Cleveland Casting works to serve the surrounding community through co-ops, internships, and educational programs. It is a facility that the greater metropolitan Cleveland area and Ford Motor Company can be proud of, as it ranks among the very best in quality, production, technology, employee relations, and citizenship, and promises to continue to do so well into the 21st century.
The Cleveland casting plant is regarded worldwide as a major force in product, process, capacity, and efficiency, and now has become a leader in casting technology. Strategic improvements and major investments account for the continued success of this plant, which has been in operation for more than 35 years. Investments in people like this pattern design engineer, and investments in equipment. With this CAD/CAM, the design engineer can review, evaluate, and develop innovative engineering concepts. One of Cleveland Casting's investments is the sand turbo blower and mixers, which serve 11 core machines. In just 3 minutes, this 15-ton-per-hour turbo blows 1,500 pounds of dry sand on demand into the sand bins above the core machine mixers. The self-contained freestanding mixer unit consists of a volumetric sand bin, resin and liquid catalyst metering pumps, vibrating motor, and mixing bowl. The mixer reduces sand consumption, scrap, labor, and cleaning frequency, while improving core quality and machine productivity. This particular core line produces components for the 5-liter engine cylinder head. The Cleveland plant also has a new and innovative synchronized core making system for V6 blocks. Acclaimed as the most modern core process in the world, Cleveland's new system has attracted foundrymen from around the globe. Its features include cold box binding techniques, automatic core definning to ensure smooth, high-quality internal casting passages, and an automated core coating and draining process. Unlike conventional processes, this new technology assembles the finished cores into one rigid core package and ships it directly to the mold line. The finishing process of the V6 block starts as the block leaves the crankcase and end grinder. Then flop-over automation picks up the block, which is rotated to a head deck up position for automatic loading of the grinder. Then the block is discharged from the head deck grinder and rolled over onto the conveyor belt, where it enters the high-frequency shakeout. The accumulating power conveyor and autoloader sets the block on the turntable, which rotates 90 degrees each cycle. Then the block enters a 16-station definer, which removes parting line flashings from holes, openings, and surfaces in the cast iron V6 block. Blocks exit the definer and are placed on a 90-degree turntable for discharge on a power roll conveyor, where they receive additional finishing processes. During the finishing process, Cleveland Casting also utilizes an automatic coordinate measuring machine, complete with computer system printer. This machine does in a few hours what used to take an operator weeks to accomplish. Ford's commitment to quality is evident with the testing of every V6 block. A leak test panel identifies the casting as being acceptable or a leaker. Blocks are automatically transferred from a power roll conveyor to a monorail conveyor. A robotic system is used to paint the blocks. After drying, the blocks are placed into shipping racks. A robotic system is also used to paint the V6 head castings. Line 7. This schematic of Line 7 illustrates the advanced technology of the vertical flask